So if you haven't heard anyone talking about data mesh yet, I don't want to say I'm surprised. But it's like when somebody tells you they haven't seen some classic movie like Star Wars or something. The good news is that they get to see it for the first time. And that's the deal with data mesh and thought worker Zhamak Dehghani. She's going to tell us how legacy data systems haven't quite delivered what we've wanted. That's probably an easy sell for this audience. And she's really going to dig into why, in a social and architectural sense, why they were not structured properly and how to fix that. Listen for her to give the 4 principles of data mesh systems. I think they're really compelling. And I think as you follow along, you're going to see that this is a system that cries out to be implemented with Kafka. It's like Kafka was waiting patiently for an idea, something like this, to come along. So please let me welcome to the virtual stage, Zhamak Dehghani.
Hi everyone, I'm Zhamak Dehghani. I'm the Director of Emerging Technologies at ThoughtWorks North America. I'm excited to be here with you today talking about data mesh, sharing my experience along the way with you and explaining what it is and why this concept came to exist a few years back. As a technology consultant, I can share this with you, that there are great expectations around data. Every company and executive that I work with has ambitious plans around data-driven initiatives sprinkled all over his or her strategy. And just as an example, I want to share a few mission statements with you. The first one is from a wonderful financial SaaS company. And their goal is bring new value and new products to their customers using AI and data that they have about their customers. The second one is from a telco in North America. Their ambition is around streamlining their workflows and internal processes to serve their customers with their staff augmented with intelligence and AI solutions. And finally, my favorite is from a healthcare provider and payer in North America. Their mission is to improve the experience of their members at every touch point with their company using data and ML. And I'm sure your company has equally audacious plans. But the inconvenient truth is that for decades almost, we've been trying to bootstrap ourselves, get to these goals with spending more and more accelerated pace and amount of spending on our data platforms, and yet failing on transformational metrics, really failing to see value based on the investments that are making. This is from a New Vantage Reports, Partner Reports, a report that I keep an eye on every year. And what it shows is that despite accelerated pace and amount of investment, the results on transformational metrics like changing your data culture, becoming data-driven, competing on data, being able to go from a thought of an experiment to getting access to the data to run that experiment and validate whether your hypothesis was true or not, we're still not seeing that sort of transformational change. The failure symptoms that I saw in the wild that triggered the thought around questioning the existing paradigm were these ones, and the most important ones are the two in the middle. The failure to scale. As we see more data sources becoming available to us, and as we become more ambitious around using that data to get value for our businesses, we're seeing these two pressure points that our existing technology solution architectures can't handle, from the input and from the output. And the solution, obviously, like the response to that is often, well, let's build our next data platform. So we find ourselves in this repeated cycle of bootstrapping yet another next data platform and ultimately failing to materialize data-driven value. So the current, let's look at the current data landscape. How have we been trying to address these these plans and goals that we've had? So I would say for decades, up to today, this is how we have imagined data. We had this great divide between operational data, which runs our, data that runs our business, the state of our stateful workloads like microservices and applications, And then on the other side of the organization, different teams, different technology stack, different architecture, we see our analytical data plane that is intended to gather data from all of those systems, put them in one big place, warehouse or lake, to be able to now run analytics or feed our machine learning algorithms to, intelligently augment the services that we have. And in between, we've had our pipelines, right, connecting the two planes. And if you zoom in to our blue box, the analytical data plane, we've had evolutionary change on the technology and our approach, right? We've had the first generation data architectures, the data warehouse, where we are getting data out of all of those stateful workloads out of our operational databases and putting them in pristine and perfectly designed canonical models that we can now run SQL queries on top of them and then visualize them. And we've had our data lake, right? In about 2010, we decided, well, this process of perfectly modeling the data is not satisfying those rapid experiments of data scientists looking for the signal within the noise and while seeing the noise. So we decided, let's get all the data out of those operation systems and yet put them in one big place, but in a more semi-structured format. And then downstream, we can model it. And now we are in this multimodal phase, right? That we put data still onto the cloud. It's very cloud driven. So, the third generation is mostly companies are getting comfortable with putting their data to the cloud, and their architectures is multimodal in a way that it includes a big storage for data lake, as well as the warehouse for analytical. And then we have the lake house solutions, which bring in kind of the SQL and transactional nature to the lake operations, to the lake storage. So we're seeing this kind of multimodal change. So definitely we've had an evolutionary improvement around the architecture. Most certainly, we've been busy building technologies. We've had this Cambrian explosion of tools and technologies around kind of data solutions and analytical solutions. I didn't put this picture for you to read the icons. It's just I put it there to have a look and feel impressed and feel dizzy that we've been busy building technology. So then what hasn't changed? What assumptions remain the same that lead to those problems of scale that we're seeing? And I want to run through very quickly some of those basic assumptions that data mesh challenges. And they're going to be a little bit uncomfortable. If you're coming from, decades of doing big data and analytics, this next few slides are going to make you uncomfortable. So the first and foremost, I think we have thought that for data to be useful, it has to be centralized in one place. And that has led to these monolithic architectures of getting data from ubiquitous sources around the organization, within the bound of the organization or outside. And, that big monolithic solution with centralized data answering the needs of the consumers. And then, as every architect knows, when we find ourselves constrained with the limitations of big data, big and monolithic solutions, what do? We try to break it into its parts and integrate those parts together. And the easiest way to decouple a monolithic solution in terms of big data solutions is often around the technical decomposition. So let's take technical pieces or technical functions or tasks that happen. Let's break up the architecture. So ingestions, processing, serving, or different modes of technical decomposition. When you do make a technical decomposition, the consequence of that is that you decompose your teams around the tasks, not necessarily the outcomes and features. So the task of ingestion, the task of serving, and the task of processing. But the change and features and adding new sources or getting new use cases addressed is not usually localized to these nicely, neatly drawn boxes. They're actually orthogonal to those. And of course, we can't talk about architecture without talking about people. So folks who are building these solutions are hyper-specialized around the technology and often are stuck in the middle between people who are generating the data, they're the point of origin for that data, and the folks that are needing the data. And they are in between trying to make sense of the data and provide that to the consumers without really being involved in the domain, whether from the use case perspective or the source and the nature of the data perspective. So in short, data mesh challenges these assumptions centralization of the data to get value out of it, and centralized monolithic architectures that are built around data, centralized solutions, technical decomposition of the architecture, and the way we have organized our team with centralized team around the big data solutions. So where do we go from here? What's an alternative? What I hope to get out of here is for you to come out of this talk and say, that kind of made sense. I could have thought of this myself. So hopefully these are intuitive kind of principles that I share with you. For decades now in the operational world, where we have seen an accelerated, number of innovations around how we build microservices, how we build the infrastructure around it, we decided that monolithic solutions don't scale to meet the needs of our operational applications. So what did we do? Based on the work of Eric Evans, we decided that a complex system is best decomposed around its domain functions, around how business it decomposes itself, right? So the first principle of data mesh is to think differently around drawing the boundaries between the components of the architecture, between the data itself, and using the natural, the evolution that we've been going down the path of over the last few decades with the operational world and extending that to data. So the first principle is the composition of the data and architecture around domains, which is how we decompose our business today. So once we do that, there are a lot of challenges that arise, right? Silos of the data. So how do we make sure the data doesn't just get siloed within one domain and not accessible? So the second principle of data mesh is really treating data as a product and building a new foundation of architecture, an architectural quantum that represents this thing that now we call data products. Well, when we distribute now ownership to these domains and we ask them to also build these data products, then we may end up with a highly costly solution, right? The technology stack and complexity around it. So the third principle around building the foundation to reduce the complexity from the team so that they can easily provide these autonomous data products. And finally, any distributed solution needs a governance that really embraces change, embraces distribution. So it's a federated model of governance and heavily relying on computation and automation in the platform layer to bring those governance concerns around interoperability, around security to life. So I'm just going to go touch on every one of these to see what does it entail. So if we imagine this centralized solution differently around domains, what we end up with, decomposition of the data based on the domain. So if you're an order management, if you're a customer management, if you're the logistics, so these are the business functions that you already have. And very likely as a modern digital organization, you have organized your teams around this and your IT systems around this. So let's extend that to the data and make every domain responsible and accountable for providing their analytical data, the temporal, time variant view of the data as it has happened within that domain, and provide that to the users. And then we end up with different styles or different classes of domains aligned with the source or the consumption or the masters in the middle, the aggregations like customers. So really the transformation around the domain thinking is to imagine data differently. Right now we imagine data as this source of life itself, as water, right? We flow it from the source through the pipelines, and we cleanse it, then bottle it, and then we serve it in the lake or in the warehouse. And I think that's a dangerous model of thinking, because we assume that data is not really usable at the source and it has to go through this cleansing process by someone else to become useful down the stream. So data mesh thinks that data actually can be useful right at the source, but we have to reinvent a new set of capabilities that what it means for data to be useful right at the source. It embraces change at scale, as we don't need just one canonical model to rule them all. We don't need one big enterprise data model, and we can think of data as really smaller models with intentional context mapping, intentional relationship described between them. Source of truth, the goal that every one of the goalposts that we've been chasing and we never reach. I think it's time to rethink that. I think we should look for the most relevant source, not just the one source. There could be many sources of the data that are available in the organization, and really change our language around pipelines. Pipelines are useful architectural styles, but they lack abstractions. They lack creating those fundamental pieces of architecture that can autonomously provide value to you. And they often result in a fragile architecture. So let's change that to move that pipeline as an internal implementation, not as the first level construction of the architecture, and decompose architectures around domain. So the challenge of distributed systems, distributed architecture, and ownership of the data around domains, that's going to cause a lot of trouble. The first question that you would get asked if you present this in your company would be, well, how is that any better than the silos of databases that I already have in my domains? Well, we need to create a new way of measuring success around data. We need to create new roles around the data ownership. And I use this kind of data as a product, as a metaphor to describe that transformation. So what does a product mean? It's kind of hard to define what a product is, right? You can talk about it in books, but I love this one attribute or characteristics that is defined by Marty Kagan as a successful product sits at the intersection of being usable, so delight the experience of its users, and it's easily usable, it's valuable, drives value, and it's feasible to build, right, from technology and business. So let's bring this to data. What does this mean for data to be usable? Let's just look at the basic usability characteristics. So I list here kind of a few of those that I think are absolutely critical in making data usable. When we think about the users of the data, so there we have the data analysts who are writing reports. They're comfortable with a set of tools that are mostly oriented around SQL querying, and then we have perhaps downstream people that want to build new views of the data, new transformations of the data, and those folks may be more comfortable around using events as the type of the data. So very first thing to really invert the model of our thinking is that every domain provide its data as products in a polyglot format, in a format that suits its users, right? So you might have customer data or order management data or multiple data products out of that domain, but that same data can be represented as tabular format, file-based, columnar for data scientists, or event-based for downstream data product consumers. But put yourself in the shoes of that data analyst, that data scientist. What does their journey look like? So the very first thing, they want to discover what data is about. They have a hypothesis. They think that maybe if we change the way we personalize the experience of our users, we're going to get more conversion from our sales. Let's say if you're an e-commerce system. So very first thing is, what data do I have to prove or disprove my hypothesis? Discover it. Can I understand the data that I found? Can I actually look at a Jupyter notebook and see how that data is being used? Can I look at its schema, semantic, and syntax and see I can use it? Is it addressable? Can I securely request access to it without waiting for weeks to get approval? Is it interoperable with the rest of the data on this mesh so I can actually connect this customer information with their order, with their user behavior on the website? Can I trust it? So there is a set of characteristics that we need to build. And unfortunately, for decades, the solutions that we're building is external to the data itself. We think that data is just this dead body of information, bits and bytes we run and we dump on the disk. And then we layer discoverability through catalogs or understandably through other documentation system. Data mesh actually thinks that at every quantum of your architecture, you need to provide these affordances within that quantum of that architecture. So what does that quantum of architecture look like? What is the smallest piece of your architecture that embeds these usability characteristics to start with? And this is a departure from the past thinking as well. I mean, if you all close your eyes for a minute and imagine, what do you think when I say the word data? You probably think files or tables, right? The static, or maybe streams. I mean, you're coming to a Kafka summit, so maybe you think about moving bits and bytes on streams. So that is definitely a component of a data product as a quantum of architecture, as the smallest part of architecture with the structural elements to do its job, which is serving data to the customers. That's definitely true. But I argue that this quantum of architecture needs to have more than that. It needs to have, of course, the metadata, all of the information that makes the data useful. It needs to have the code that is serving and transforming it with it, and it's part of the infrastructure that it can run on it. The fact that microservices has been so successful, we have come up with the idea of a container that contains APIs to get access to the logic execution itself, and the data that microservice encloses. So I hope that we can bring a similar self-sustaining container for data, this architectural quantum I call data product, on a mesh. And that's what we've been trying to build for the last couple of years. So transformation from a data to a data as a product really needs us, again, to change mindset and language. We use this language of data is an asset. So if data is an asset, what do? You just want it for yourself. You want to hoard it. You want to collect it. You want to have more of it. When data is a product, how do you shift that perspective? You actually want to share it. You get measured, not by how much petabytes of data or thousands of data tables you have. You get measured by how many users do you have for your data, how happy they are, their net promoter score. So we will shift with the measure of success and our behavior, our language and our behavior and the design of our systems. And I think that instead of data being just an output of code that we run, the data and code for analytical data as a data product adjacent to your microservice becomes one unit of architecture. All right, so we've put a lot of demand on our domains to provide this data as a product. What support can we give to our domains? So today, technology landscape, you saw that in the slide from Matt Turk, is full of technology, all very complex to manage. So the idea of data mesh is that we've got to somehow reduce the level of complexity and abstract that into our data platforms and ML platforms. And platform building is an idea that we're very familiar with, and platform teams and platform infrastructure teams to be able to kind of create this self-serve layer of capabilities. And even though I'm simplifying here as one layer, but we're really talking about a new class of capabilities. So today, working with a lot of organizations, we already have a data platform team of some sort, a data infrastructure team, and they give you self-serve capabilities to work with the utilities that you have, right? Work with your big data storage. Do you want, do you want a warehouse, or do you want a topic on your event stream? Like they taking care of those utility layer backbones that would run this mesh. But in addition to that, when we think about reducing complexity, breaking down silos between those hyper-specialized people, we need to rethink and reimagine our platforms differently as well. So for the experience of a data product user, or improving the experience of a data product developer, we really need a new experience layer or experience capabilities to be able to very easily, declaratively produce these data products or version them or secure them. And most importantly, once you distribute the data over a connected mesh of data products, then we need to have new experiences at the mesh level, right? Manage the graphs that these data products develops, manage the security at scale across the mesh, be able to query and discover data across the mesh. So there's a new set of capabilities that really need to be imagined, thought about, designed, and implemented. Again, there are a few transformational thinking that needs to happen, and I want to just touch on a few things. And I think we, in the infrastructure space, in the platform space, there are some distributed solutions, but not enough. I think we need to rethink about distribution. I mean, Kafka is a great example to enable distributed architectures, but we need to build upon that and create more of those solutions. And instead of really thinking about mechanics, like I hear this word data catalog, it's a hot topic. Everybody's building a data catalog, but data catalog is a mechanism. It's a mechanics how we can mechanically provide a certain experience. So let's step back and think about that experience of discoverability, searchability, understandability, and maybe that opens up a new set of tools than this static mechanics of, data catalog, and think about our users of this platform as specialists and instead of thinking that there are specialists, think about that they're generalists. Everyone with a bit of an empathy for data or interest and curiosity would be able to go from that hypothesis to delivering a data-driven solution. Well, we need a new world order, right? We've distributed the data, we distributed the ownership and accountability. This makes folks who are in governance very, very uncomfortable. And I feel you. I know you have had big, enormous like responsibilities and accountability as a centralized function in the organizations. You've been responsible to make the data secure and quality data available to everyone, accessible at enterprise level. So this really changes that model of operation. We need a new way of governance that embrace first and foremost decentralization. So push the responsibility of ownership and accountability for quality as close to the source and as close to the people who are most intimately familiar with that data, to the domains themselves. We've got to think about interoperability as a big aspect. So if I have customers represented in 2 or 3 domains, how can I actually get that customer information interoperable? So there's a set of techniques that come around that. And we've got to embrace dynamic topology. I mean, data products will be created, will be removed, will be revisioned, new versions of it will come online. So what does the governance look like if we need to embrace dynamism? And finally, we've got a platform. We have powerful technology today. Let's automate and let's use automation and computation as a way of enabling. So as an example, if we move the quality back to the source, to those points of origin and say, you are responsible for analytical data generation, the governance team is responsible for defining what quality entails, like what SLOs we need to describe a data that is of quality. And then it's the accountability of domains to say, I guarantee these SLOs, I guarantee how timely my data is going to be. I'm going to guarantee how much missing events I might have or may not have. What's the accuracy of my data? And then I will, use the platform capabilities, the testing, the automated testing, integrated testing, and all of the other observability kind of capabilities around the platform that platform gives me to get my data product to assure that quality. So essentially, we need really get rid of this idea of that we have to put a straitjacket over our data to canonically model it to be able to really use it. So the mind shift around this, really thinking about, instead of thinking about governance as one centralized function, thinking about it as a federated function with the domain owners, domain data product owners coming together, instead of them be responsible for execution of all those compliances in terms of quality and security. They are responsible for designing what those entail, but then it really gets to the platform to enable that and the teams to adopt those, right? And putting the accountability incentives and accountability structure in place and get comfortable with, we will have multiple domains and those domains are distributed, and really changing the measure of success. How do you know your governance function is successful is not how many petabytes of golden stamped, approved data they have. It's really about how many connections on that mesh you have created between your data products, the representative of how much we're getting value from that data, how easily people can use the data that we have. So in short, data mesh really is in a paradigm shift around architecture, organizational structure, and technology that supports that. And it embraces a federated computational governance with a set of global principles that get embedded into every domain. We are bringing those analytical and operational plane closer to each other based on the same team. So we will have domains responsible not for a microservice, but also for their data products, and data products get served really as a product that's shareable with set of standard protocols for interoperability and getting access to the data. And the platform, really a self-serve platform of multiple planes of providing seamless experiences for data product developers and for data product owners. And where do you get started? So my journey of 1,000 miles begin with the first step, and you have taken the first step coming listening to me. There will be more content available. There are communities are forming around data mesh online on Slack. So I hope to see you in those communities. And thank you for being here and listening to me.